This question was asked in the GATE Physics paper 2021. This is a MCQ type 1 mark question, and this question is from the topic solid state physics, specifically from the chapter dielectric properties of material. The question is, choose the graph that best describes the variation of dielectric constant epsilon r with temperature capital T in a ferroelectric material where Tc is the Curie temperature. So there are four graphs given. We have to identify the actual graph which describes the variation of dielectric constant of the ferroelectric material. So let us see the solution to get the proper graph for the ferroelectric material. Ferroelectricity is the state of spontaneous polarization in a material, that is, the polarization of the material in the absence of an electric field. So this ferroelectricity is analogous to ferromagnetic property of material or ferromagnetism, which represents the state of spontaneous magnetization in that ferromagnetic material. Now, the materials which exhibits ferroelectricity are known as ferroelectric materials or ferroelectric crystals. The examples of such materials are BaTiO3, that is barium titanate, K(PO4), that is potassium dihydrogen phosphate. There are some other materials also, etc. Now, the dielectric constant of ferroelectric materials varies as the temperature increases or decreases. The variation of dielectric constant with respect to the variation of temperature is described in the Curie law. So this Curie law depicts that the ferroelectricity disappears above a certain critical temperature known as transition temperature or the Curie temperature or Curie point, that is Tc. So mathematically, the Curie law says the dielectric constant depends on the temperature in this way, that is A by mod of T minus Tc, where A is constant, T is absolute temperature and Tc is the Curie temperature, which is also known as phase transition temperature. So this temperature of the ferroelectric material, if it is less than Tc, then it is in ferroelectric state, and if it is greater than Tc, then it is in paraelectric state. So in the paraelectric state, as the temperature increases, the dielectric constant starts to decrease. Now we have already seen from the Curie law, the dielectric constant as a function of T for the ferroelectric materials is given by this. So here, if T greater than Tc, then the material is in paraelectric state, and if it is T less than Tc, then the material is in ferroelectric state. And T is equal to Tc is the phase transition from ferroelectric to paraelectric state. Now, if we plot this function, this epsilon r as a function of t, then first it will increase up to Tc. Then if the temperature is greater than Tc, then it starts to decrease. So our option A, the plot given in the option A, is the correct answer for this question. So according to our solution, we found that the option A, that is the first graph, describes the variation of the dielectric constant epsilon r properly with temperature in a ferroelectric material, where Tc is the Curie temperature. So Tc is actually the phase transition temperature from ferroelectric phase to paraelectric phase.